Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome you in lecture 2. Inshallah, in this lecture we will analyze overhang beam and overhang beam, and inshallah you will see that in this example inshallah we will analyze the beam for both point load as well as for joineer. Okay, so you can basically need to determine first of all that we see that AC span is there is A, B, C, D points. Okay, at B point, which is 4 feet to the right of the point A, is now 900 found. Okay, and C point is lying at a distance of, you can say, 12 feet. Okay, from A, and there you can see that CD is overhang portion, while in the first example this the overhang portion exists at the left side. Clear? So let's see how we can analyze. The same steps will be followed in SAP. Okay, you just need to select new model, select the same beam. Okay, and then you need to select two spans. First of all, I want to mention you, okay, before coming to the new template, you must need to know about your units. Okay, that is found and feet. Clear? So therefore you, by just knowing your units, okay, you need to select your units, that is must be ensured from this kernel units, that is you can see found foot system. Clear? You need to bring a new model. Okay, so from here you can select beam. You have two span. Clear? The span, you just need to select the span that is 12 feet. Okay, now it will take both span equals to 12 feet, so you need to edit that grading, that grids, okay, that span length, because one is 6 feet and the other is 12 feet. Okay, so therefore you need to text, or you can say tick this box and edit grid data. Clear? You need to select your units. Okay, found, foot and Fahrenheit. You need to select spacing. Clear? Here you can see that from A to B, from A to B, you must know in SAP A point is there and B point is there. So from A to B, this span is 12 feet, and from C to D there will be in SAP basically A to B and B to C. So B to C span will be 6 feet. Clear? So you must one time, if you understand this grid spacing, that how we will adjust this spacing, at the rest of lecture it will be more easy for you. Okay, so you must to clearly understand that how we can define grid spacing. Clear? So from A to B, that is 12 feet, and from B to C, that is only 6 feet. So you need to just insert 6 feet and leave the rest of the data. Okay, just blank. Clear? And from there you can see, you can hide your grid lines and the bubble which you are seeing here. Okay, this kind of bubble, so you can minimize or maximize their size. If I insert only one, let's say one, you will see the bubble size will be minimized. Okay, so okay, and then okay. Clear? Same in the first lecture. Okay, we will delete this option. Clear? And you need to select exit plane. Clear? And this is the bubble size. If you insert larger value, so this size will be larger, and if you will insert smaller value, this size will be smaller. Okay, so from A to B we insert 12 feet, and from B to C we will insert 6 feet. Clear? Now we have to remove this joint. Clear? This joint, because the portion from B to C is overhang. So if you want to remove this joint, you can not delete this directly, this joint. Okay, you have to follow the same procedure just by selecting
just clicking on the joint, go towards assign menu, just select the joint option and then select the strand. Clear? From here you just select this point, okay, and okay, so your joint will be unchecked. Clear? One thing you must ensure that you need to check these joints, okay, whether it is ruler or not. Clear? So you can see this is blank. This means this is just only a point, not a joint. So there is a ruler support, okay, there is a ruler support, okay, and you must need to check this one, this joint as well, okay. Just coming and just select the hinge. Clear? So you must ensure these joints, because once you make changes there or you delete the joints, so it will make some kind of changes in both these joints. One thing you must know that there the, 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 the rulers or hinge is not shown here, okay. So this sign, it is a kind of simply supported structure, okay. So this means that there is hinge and there is ruler, or there is hinge, there is ruler, okay. So in any case there will be any simply supported beam, whether it is overhang, whether it is simply supported, you must know that it should contain one hinge support and one ruler support. Clear? So now you can scroll it, okay, by just pushing the mouse button, or either by selecting this pan option. Clear? You can move the beam anywhere you want. Clear? And similarly zoom in and zoom out will be work here. Clear? And similarly if you want to zoom a specific portion like this, okay, and if you want to back the same view, just clicking this option. Clear? And you must ensure that you will be in exit plane. Clear? Because in XY plane it will be shown in a different way, YZ plane it will be shown in different plane, okay, but you have to select exit plane. X is the horizontal, Y is Z is the vertical plane. Clear? Similarly you can select 3D, and okay, this is 3D view, and you can rotate it, okay, the beam you can be rotated, okay. So this is exit plane. Clear? So some option I will want to clarify, okay. I will define all these other option as well, okay. So similarly if you want the this option is important. Clear? If you want, because you can see there is a white background on my screen of SAP, okay. If you want to make it black, so you can make it black, because most of time the background of this SAP program is black. Clear? So you can make it black just selecting this background color and choosing it to background color will be color solid, that is black, okay. Select it and okay. So you see that your background color now comes out to be black. Clear? Now here we are assigning our loads. Clear? So if I want to assign the loads, okay, you must ensure that you will be in exit plane, okay. So this is the way that how you can change your background, okay. If you want to change it again to white color, you can select the same option menu, color display, and then just select the white color, you will get again the same option. Now we are going to assign the loads. We will assign the joints. Now we will assign the loads. For that purpose you need to select it and the whole beam span length, okay. If you do not select it in this way, you can select it through by using this option. Select all. If you select this, okay, if you press this button, your joints will be selected. So you don't need to select the joints, so just by clicking it your joints will be unchecked. Okay, now you need to assign loads. Clear? So just select the assign menu, comes to frame loads, and select the distributed load. So first of all we will want to assign the distributed load, that is 60 pounds per foot. We follow the same procedure. We select the dead load case and we make the multiplier equals to 0. Clear? And just by pressing the modify load pattern and OK, now the self weight multiplier of the beam becomes 0. This means that self weight should not be counted here. You need to select your unit should be in pound feet because load is in pound. You need to check this button. Clear? Your axis should be global and your direction will be gravity. Okay. Similarly, you need to select the absolute distances. Here you can define basically the load is throughout the span, so therefore we don't need to use this kind of spacing. Clear? We just only insert 60. If it is not on the whole span, then we will use this spacing. Clear? So 60, we will use this spacing. Clear? In coming example. Clear? I'm going with a step-by-step procedure. Okay, not just defining all things in one video. Clear? So just insert 60 pound, okay, per pot. This is the load, UDL load. You will see that this is the load throughout the whole span. Clear? Then you have 2-point loads. Okay, one at 4 feet distance, now so you can say 900 pound, and one at the free hand. So first of all we will assign this load and then we will assign 400. So we will select because 900 load is on this span. Clear? So by just selecting this span, coming to assign frame loads and selecting point loads, your self weight multiplier, once you make it 0, it must be equals to 0. Clear? So it is a one-time job. Clear? Your unit should be pound feet and you should select this option. Clear? Gravity, global, and you have to select this checkbox button, and here you can just insert 4 feet because the load now so feet present at a 900 4 feet from support A. Clear? This distance should be measured from your left side. Clear? So at 4 feet you have a point load of 900 pound. Clear? So this is your load. Clear? Now you have to assign another load at this free end. Clear? So you just need to select this. Clear? Coming to assign menu, selecting frame loads and then point load. Clear? Your self weight multiplier is 0. No need of checking it. You need to check this unit box. Okay, you need to select this option, add to existing load. Your direction must be gravity. Okay, if there's sometime you will see it may happen that the load will acting in upward direction, so then you cannot use this gravity option. Then you will selecting your z direction because the load is acting in upward of z direction, so you will select your z direction. But now the load is in downward direction, therefore you need to select gravity. Clear? You need to check absolute distances, and here you can select 600, okay, sorry, 6 feet, and the load is now 400 feet. Clear? 400 feet because the distance is measured from this point, okay, from your left side, and from left side at a 6 feet you have a load of 400. So let's see. Now this is your load. If you want to if you want to see your loads, whether your load is assigned or not, you need to select display. Okay, then you need to select show loads. Okay, and then you need to select frame option. Clear. And then you can select your dead load. Clear. And there span loading. Clear. Okay, so here you can select your span loading. Okay, and show joint loads with span loads. No, show span loading only. Clear. So uncheck this and okay. So this is your total loading. If sometime if you become confused that whether my load is assigned or not, so we will use this display option. Clear. Because it is useful command. Clear. Because if you assign one type of load and then if you want to assign another type of load, so your first type of load which you will assign to the system or to the beam, they will be deleted. Okay, they will don't show that load. Okay, so therefore you need to confirm the loading, whether the total loading is assigned or not. So it is easy. Coming to display menu and select your show load assign, and if you want to see your joint loads, if you apply any kind of joint loading which is assigned to your joints. Okay, sometime we assign displacement or rotation to joints. Okay, so this option will be used. Okay, now we will assign loads to frame. Okay, so therefore we will select this option. If you have load cases or load pattern, then you need to select your proper load case. Clear. You need to choose your span loading. Clear. And in span loading you need to show only span loading values, so you see those. Okay, so now our beam is completed at this up to this point. After that we just need to save the model, and then we need to analyze the model. Clear. So by just you can select the run analysis button, and as well as the analysis can be run by just pressing the F5 button. Okay, so F5 button or just pressing this button. Clear. As usual you will select model and check this one. Clear. And then select run now. Clear. Same, you have to save the model. Okay, UDL and point load. Okay, overhang with UDL and point load. Clear. So once you save the model, this is the bending moment diagram. If you want to see the joints reactions, first of all you want to see the joints reaction. Clear. There should be dead load here. Okay, and you need to select your proper load case. Okay, here we have only one load case, that is dead load. Clear. And you just need to click OK button. Clear. So at one point you will see 1710 pound and 670 pound. Let's see, we will check it. So this RA is 670 pound. Okay, and the RC is 1710 pound is okay. Clear. So the reactions are clear. Okay, now we will want to see the shear force diagram. At one point we have 670 pound, and then at decreasing to 430 pound. Okay, and then it will further decrease to minus 470 pound, then it will come increasing to 950, 760 and 400. So let's see. The same way you select this button, frames. Clear. your proper load case, and then you select share to as usual. I will explain in first lecture. Okay? So that is your share about to do. Clear? You need, if you want to fill diagram and if you want to show values. Okay, so we will need to show values. Okay, we need values. So okay, and these are the values. Clear? So you see 670. If you want to the values of this point, this point, you know, you just bring the cursor here and press the right key. You will see there. Clear? So it will showing you your maximum minimum value, and by selecting the scroll option you can see the values at right at this point. Clear? So that is 470. Okay, and the maximum bending moment. Okay, this is the maximum moment diagram. Okay, this is the moment diagram. Okay, and okay, done. So the diagram is clear. If you want to make clear this text, so as previously I will explain this procedure, that you need to select your option. Okay, and in option you need to check your these two values. Minimum graphic size must be, you select it, let's say this is 8, and maximum graphic will be, let's say 12. Okay, you can give any values. Okay, so it become enlarged. If you want to make it more large, you just use the window zoom button. Clear? So 950 and 760. So almost our diagram of shear diagram is clear. Now we want to check the movement diagram. Clear? So same this option. Okay, this button, and here you can select frame and proper load case and select the movement about 33. Clear? Okay, so there you can see 2200 pound feet and 3480 pound feet. Okay, so let's see, we will check it. This is 2200 pound feet and 3480 pound feet, and here again we have a point of inflection. So if you want to find out the point of inflection, you need to, because the point of inflection in this positive zone. Okay, so you need to bring the cursor here and just press the right key. Okay, so once you press the right key you will show this diagram. Clear? So select the scroll option and bring your scroll just at the point of inflection where your uh, you know your movement comes out to be 0. Clear? So here you can see your movement. You can see here your movement is converting from positive to, transferring from positive to negative value, means there is 0. So you need to select the proper one. Okay, 0. So then you can get your exact value. Clear? This is -6. It is very close. Okay, okay, so roundabout 7.76 roundabout, I think so it will be 7 feet or 6.9 roundabout. Okay, because the selection at right at the 0 point is very difficult by scrolling. Okay, so let's see. This is, this is from the mid point. Clear? This is from the mid point. If you are interesting here, this distance is basically measured from from this point, I think so. It is not from the peak point. Okay, so there, if you want to check it, this distance is now increasing and reaches to 1100. So basically the distance is measured from the support. Clear? This 7.76 is basically the from the from the support. Clear? If you want to that what will be the what will be this distance from the maximum, so you make them for that purpose you need to make calculation. Okay, show maximum value. So this is your maximum bending moment diagram. Okay, if you want to, because your shear is zero there. Okay, so you need to bring the cursor or the scroll just above the 0 point. Okay, and now you will check your the moment, the maximum positive moment, that is 2171. Okay, I think so that's value is the maximum positive value is 2200 found. So you need to find out the distance of this movement from this point, and this point can be easily determined from the shear value, because you know the bending moment will be maximum where the shear comes out to be zero or becomes to zero. So you can see that the shear is zero at a distance of 4.053 feet. So your this point will be at a distance of 4.053 feet. So here you this zero or point of inflection is around about 6.9. So just only subtract 4.053 from 6.9, so it will be around about 3.772 feet. At this moment we don't need to calculate these point of inflection. I want to show you that how we calculate or how we will determine this point of inflection. It is necessary because if you are doing your PRC designing and you are finding out the distances of curtailment like bending bars, okay, cut up bars, so in that cases you need development length. Okay, so where we need basically to look at the point of inflection. For that purpose, if you are doing them manually, so it is a very difficult job. You will make some kind of equations for to find out this distance. So if you have safe, and you know about this calculation, so you can easily find out. I think it is enough, and see you in next lecture. Okay, so if you have any question, I welcome. Thank you.